Hey Opties! Today we're going to talk about function evaluation. So we're looking at different types of functions written in function notation, and to evaluate those we will substitute x values into the equation and find our y value or our outputs. Let's take a look at the definition of function notation. So typically when we have a function, it is written as y equals 3x plus 1 or y equals x squared minus 5. It's typically a y equals. Function notation is just another way of writing y. So instead of writing y, we sometimes will write f of x, and that looks like an f and then an x in parentheses beside it, and that's just the same thing as y. The reason we might write f of x, g of x, h of x, or p of x is because it makes it very easy to tell when we are substituting a specific x value into the function. So not only will we see that substitution on like the meat of the equation, typically the right-hand side when you're most often writing equations, but we'll also see it for the y side. So it's mainly for notation purposes. Let's go ahead and take a look at an example. Here we have a function f of x. We can also call this the function f, and it's 2x minus 1, so it's a line where it has a y-intercept of -1 and a slope of 2. We are finding f of 5, so we are finding what y value occurs where x is 5. So we substitute 5 everywhere we see an x. So if we look right here, the first line is f of x is 2x minus 1. And we substitute that 5 in for the x on f of x side and the x from the 2x minus 1. And now we just simplify the right-hand side of the equation. 2 times 5 minus 1. 2 times 5 is 10. 10 minus 1 is 9. So what that tells us is the point 5, 9 is a point on this line or this function. These 3 little dots mean therefore, so that's what this sentence says. Therefore, 5, 9 is on f of x. We can also look at function evaluation graphically, not just algebraically. Here we have a graph of the exact same function f of x. It's already graphed for us, and there are 3 points on the line that are plotted for us. Again, we want to find f of 5. So if we see where 5 is on the x-axis right here, it's also written for us. Now we just need to figure out what point is on the line where x is 5. So we can see that the function has a point up here, and it says 5 comma f of 5. And if we want to find what f of 5 is, which is that y value for an x value of 5, we can just look over here on the y-axis and we see it's 9. To verify, we could also use the algebraic method if we were given the equation. Since it's the same equation, we can tell that it is 9 because we just did that algebraically as well. So now we're going to do some practice. Number 1 asks us to find f of -2 if f of x is 3 times the absolute value of x minus 2. So let's substitute -2 in for x. F of -2 equals 3 times the absolute value of -2, because that was an x as well, so we're also going to substitute there, minus 2. Let's keep our notation of f of -2. The absolute value of -2, that means how far is -2 from 0? Well, that's just a distance of 2. And you can also remember that absolute values make negative numbers positive because distance is always positive. So this absolute value of -2 is just simply a 2 now, and we'll be multiplying that 2 times with 3. I'll go ahead and continue with my equal sign. 3 times 2 is 6. 6 minus 2 is 4. So this is what it tells us. Therefore, the point -2, 4, is on f of x. So it's a point on the curve, or in this case, for absolute value, it looks like a big V, right? A big V shape for our function. And that point is on that curve, that function curve. Number 2, find g of -1 if g of x equals 2x squared plus 4. So again, we're going to substitute -1 in for x. So g of -1 equals 2 times -1 squared plus 4. Keeping our g of -1 for our notation. Now remember, when I write this -1 in place of x, that means I'm substituting into the function. It doesn't mean g times -1 or anything like that. I know that when we're having the parentheses over here, it means multiplication, but that's not the case for the function notation. So -1 squared is -1 times -1, which is +1. So that's going to be 2 times a +1 plus 4. Keep my equal sign. 2 times 1 is 2 plus 4. And that's 6. Therefore, we know the point -1, 6 is on this function, which is g of x. Number 3, find h of -2 if h of x is -x cubed plus 6. So let's substitute our -2. Always put your substitution in parentheses. Sometimes it won't change the math, but sometimes it will. And it's always just a good tell that, hey, I'm substituting here. Because sometimes if you don't do parentheses, it will mess you up. All right, h of -2. -2 cubed is -2 times -2 times -2, which is +8. So, but this negative right here will stay the same. So that's going to be a -8 plus 6, which will be a -2. So, therefore, -2 comma -2 is on this function curve, so it's on h of x. And since this is a cubic, that's going to be a Superman curve. Number 4, we are going to do this graphically, and then we're going to check algebraically. So we want to find p of 4 if p of x is equal to the square root of x minus 1. So looking at the graph, the curve is already drawn for us. Remember, this is a square root, so it's like an angry eyebrow or an arrow shooting off into the distance. So let's look for the x value of 4. That's 1, 2, 3, 4 right here. That's our 4. So what is the y value for that? It looks like it's probably a 1. But the thing is, with graphs sometimes, it can be hard to tell if it's exact. That's why I want us to also check algebraically. So let's do that. P of 4 is the square root of 4. Now, you can put parentheses here, but your square root's already kind of like a grouping symbol. So it wouldn't really matter too much there. I'll do it just because. P of 4, square root of 4 is 2. And 2 minus 1 is 1. So therefore, we were correct, so it was at 1, so that's good. 4 comma 1 is on p of x, and we can tell that from our given graph. that's the whole way we found our answer graphically, because we were looking for the point that was on that curve.